Hello everyone, this is Dr. Yaseen Sheikh from Abeda Inamdar Senior College. I am from Chemistry Department. I just want to go on to share with you this amazing slide of the hydrocarbons. What is hydrocarbons? Did you know about hydrocarbons? Yes, I will share you the very excellent slide of the hydrocarbons. Hydrocarbons, the compounds which consist of hydrogen and carbon are called as hydrocarbons. Did you know about this? Yes, I think you know about this, but unfortunately the many of the students doesn't know about what is hydrocarbon. That this specifically it means the hydrogen and the carbon. Yes, now they are the classification of hydrocarbons, how they are classified. As we know about the many things about the various compounds, but basically the hydrocarbons are classified into the two basic main compounds, that is the open chain compounds. Yes, it's very important, open chain compounds and the closed chain compounds. What are the open chain compounds? The open chain compounds are the saturated and unsaturated compounds. Yes, we know about the closed chain compound also, where it is divided into homocyclic and heterocyclic compounds. Now, the various open chain compounds, can you imagine? Yes, it is in front of your screen. It is given as a open chain compound. Yes, these are the alkane, the example, the beautiful example of alkane in the open chain compounds. We all know about this. This is the basic thing about the open chain compounds. Now these are the alkenes, the carbon double bond, and with the immense of chain compounds. These are the various examples of the saturated, unsaturated compounds. Yes, now the very important that is the third carbon triple bond, that is alkyne, that you have on the screen. Now what about the alkene and alkynes? We are going for the aliphatic. Yes, as we know about the classification of hydrocarbons, now we can go for the distribution of the open chain compounds, that's the saturated compounds, which is considered into the alkane, alkene and alkyne. So what is alkane? Alkane? Yes, alkane is a saturated hydrocarbon which consists of only single bonds. Yes, a carbon-carbon single bond. That is the example, the methane molecule, which is a saturated hydrocarbon, that is only carbon-carbon bond. And we can also have the carbon-hydrogen bond that we have from the, yes, we can have the saturated hydrocarbons, that is only carbon-carbon bonds, and we can also have a carbon-hydrogen bond, that is a beautiful chain compound. The example have you written in the on your screen on the left hand side or right hand side of the screen, that is a methane molecule. The alkane have the carbons which are arranged in the chain compounds. Another name for an alkane is the aliphatic, that is a fat. Yes, there are given in the screen, that is a three different structure. There's a one in chain compound, a second in is the 2D methane molecule, which is having a beautiful structure, and the 3D molecule, which is having a methane molecule on right on your screen. Please check it out. The next, how can we, yes, how can we calculate, how can we determine the molecular formula of the alkane molecule? There is a general formula which is written in the CnH2n+2. This is a general formula for the molecular formula. How can we calculate the molecular formula of alkane? There is, for example, methane molecule. if suppose we have to take a methane molecule, number of carbon atom, the screen is given you the very tabular form, a very simple tabular form. How can methane calculate the molecular formula? First is methane molecule, the methane molecule which is having the value of, we just want to put the value of n in this general formula. That is the general formula everybody knows, CnH2n plus 2. Just want to put the n number of molecule and number of carbon, sorry, and number of carbon, we get the required formula. Yes, that is we can have we can have the wait, we can have the, yes, we can have the methane molecule. Just put the carbon, that is the CH4, n number of carbon, C and H2n. That is, if carbon is 1, that means the molecular formula becomes of methane is CH4. If number of carbon is 2, that is in ethane molecule, we can have C, that is Cn, that is the n value of 2, that is C2H2 plus 1, that is the number of molecule of carbon is 2, that is 2 plus 2 is 4, and 4 plus 2 is 6, that is the ethane molecule. We can have the molecule C2H6, and the rest of you want to calculate on yourself. Just practice it. Practice makes man perfect, and you have to practice. Yes. So we have we'll classify these things into the preparation and the preparation of how we can prepare the alkanes. We have to synthesize alkanes with the help of, yes, very first and very important, that is the catalytic hydrogenation reaction. How the catalytic hydrogenation reaction occurs? Very first is what? The alkenes and alkynes on catalytic hydrogenation gives alkanes. That is having a general formula. We can have, always remember, when we have to prepare something, when we have to prepare alkane, we should have the preparation afterwards. That is, we have to prepare alkane, then we have to prepare alkane from alkane. So be very confident about it, and very you just want to focus what to prepare and from where to prepare. Just number the catalytic hydrogenation. That means what? With the help of catalyst, we have to do hydrogenation. Yes, we have to do the hydrogenation reaction. For example, here it is written on your screen, that is, yes, we can have this example for the alkanes. How can alkanes are prepared by catalytic hydrogenation? Yes, very first reaction we can see here, the alkenes are, yes, on hydrogenation in presence of nickel. We can have a temperature of 200 degrees Celsius. We are providing the energy. We are providing the energy in the form of heat. So we can have the alkane, beautiful alkane. Yes, similar example, we can have the alkynes also in presence of hydrogenation and in presence of nickel. We can have on the 200 degrees Celsius. This condition, energy is providing, energy is very important into these reactions. Yes, we can have, yes, beautiful alkane. We can use a catalyst, a nickel catalyst, used in the finely divided form because it increases the surface area. The powder form increases the surface area. That's why we are using the nickel in use in the finely divided form. That is, if platinum or palladium are used as catalyst, reaction occurs at a normal temperature. Also, sometimes the uranium nickel is used as the catalyst. You have to remember this catalyst, very important. The catalyst will be very important factor for the completion of the reaction. For the completion of the reaction, it's very important. How can you use the, yes, the very next is what? Uranium nickel is an effective at room temperature and atmospheric pressure also. So this is having the very easy reaction, how we can synthesize the alkanes. Yes, in presence of the hydrogenation, catalytic hydrogenation. There's a very important note: when the hydrogenation of alkene is in thermodynamically a favorable reaction, that means it will not proceed without any addition of catalyst. Very important note. You should remember this. You should remember this. Please note down, if you are writing this, please note down on the above the road book, that is hydrogenation of alkene is thermodynamically favorable reaction. It will not proceed without the addition of the catalyst. Very important catalyst. We can see the next how the preparation of alkanes can be. The second most important reaction is what? The Roth reaction. Roth reaction. Yeah, it's Roth. What about Roth? You should know about this name of the scientists also when you're going to tackle with the reactions. If you remember the scientists, how they work, how they work. Eventually they work day and night. They are they are surviving for this reaction. They are because of them we are surviving. Actually, they are the reason for surviving us in the chemistry. The Roth reaction. Yes, it's a reaction of solution of alkyl halide on treatment with the sodium in presence of dry ether gives alkane. Yes, this is a very, very, very easiest reaction. You can have this reaction till your PG courses, UG courses. Yes, we have the Rx plus Na, that is a sodium in presence of a dry ether. It's very important how we are using the ether in the form of a dry form, and we'll get a very simple. This is the general formula. We can use the reaction also. This is the general formula for your for your vessel. And alkyl halide on Roth reaction leads to the formation of a symmetrical alkane having an even number of carbon atoms. Very important. The two different alkyl halides on Roth reactions. There is a beautiful air over here, so I'm enjoying this also by so yes, two different alkyl halides on Roth reaction gives a different alkanes having a similar range of the boiling point, and hence it is very difficult to separate the product by a fractional distillation. And when the zinc is used in the Roth reaction in place of sodium, the reaction is named as the Franklin method. This is a very important, the Franklin method. Yes, even though Roth reaction, Roth is a French scientist who has worked a whole life he is into the reaction, chemical reaction, but still he is having some limitation about this reaction, because every man cannot be perfect. It's a set of examples. Every scientist worked harder and harder and harder, but they are having some limitations even in the last phase of their lives, because the technology and the different sources are available. So how the Roth having some limitations? Very first is methane cannot be obtained by this method. Yes, methane cannot be obtained by this method. The reaction falls in case of tertiary alkyl halides. Yes, it's a tertiary alkyl halides. Did you know about the tertiary alkyl halides? What is a tertiary alkyl halide? Can anybody guess? Yes, think. You have only 5 seconds. 5, 4, 3, 2, 1. Yes, this is the tertiary alkyl halide. Yes, the carbon which is attached to the halogen. Yes, it is that carbon is called as the tertiary carbon. Here in this your screen, the halogen is chlorine. Yes, the chlorine is a halogen attached to the carbon is called tertiary carbon. Yes, in case of dissimilar alkyl halides, it is difficult to separate the product, as they have a very less difference in the boiling points, because the very, very important factor in the organic synthesis, that is the physical constants. The physical constants is very, very important. Yes, and there is a very less difference in their boiling point. Physical constants means the melting point of the compound and the boiling point of the compound. Yes, we have very important. Next is how it mechanism of the Roth reaction, how it works. So we have, yes, we have the mechanism of Roth reaction. is although not clear. However, two mechanisms are proposed for this reaction. That is, with the very first proposed mechanism of Roth reaction involve the formation of the intermediate organic metallic compound. That is the organometallic compound. This we have, yes, a simple example. That is whenever the mechanism of the Roth reaction, the very first is what? The mechanism is not very clear, so it forms its intermediate. Yeah, one message there, one snapshot also, so that's why it is breaking as screen. So yes, we can enjoy it. Okay, be natural, don't be very sophisticated, and don't be very, be natural. That's why I have prepared this in a natural form. So this is a reaction where the sodium is, form its intermediate, and we'll have the very next step, the alkanes. Yes. So supposed mechanisms. This is the proposed mechanism of Roth. This is the second proposed mechanism. We can have the radical. There is a two formation in the mechanism. There is a two important factors. That is, one is from the intermediate and another is from the radicals. So you remember this. This is a very important factor. The next is what? Kohlweiss synthesis. He's a German scientist. Kohlweiss synthesis for the electrolysis method. He's a German scientist. He worked a lot of things. He did a lot of exercise on the synthesis, and he made the very crucial and very important synthesis. That is the Kohlweiss synthesis. Alkanes are found on the electrolysis by concentrated aqueous solution of sodium or potassium salts of saturated monocarboxylic acid. So we have the general formula over here, how it is concerned. So yes, now we have the very number 3 synthesis. That's the Kohlweiss synthesis, as we discussed earlier. There's a scientists have worked a lot for the chemistry, for the chemical reactions. They died during the while having the reactions of their table, and they died. This type of scientists we have, by the almighty grace of Almighty, we have to have this type of scientists. That's Kohlweiss synthesis. He's a German scientist, and he has having a Kohlweiss electrolysis method, or we can say Kohlweiss synthesis for preparation of alkanes. The alkanes are formed on electrolysis of concentrated aqueous solution of a sodium or potassium salt of a saturated monocarboxylic acid. We have the journal formula on your screen. That is the sodium salt of fatty acids on electrolysis give you the alkane, and we have the example of the same. And we have liberate in this type of reaction, we can liberation of the carbon dioxides. This method is used for the preparation of ethane and higher alkanes. Do remember, there is a very important point, guys, that this method is used for the preparation of ethane and higher alkanes. Remember, it's very important. Yes, another method for preparation is the Grignard reagent. How we can prepare the Grignard reagent to prepare an alkane. It's very important. How we have Grignard reagent is the most known reactions that all we have know from the basics of 9th standard, 10th standard, 11th standard. We know this the reaction Grignard reagent. He's a blessed scientist. I should say he's a blessed scientist. The Almighty has given him the gift of this reaction, because about the Grignard reagent. If you don't know, just go and read the story of Grignard, how he gifted the reaction. God has gifted the reaction because of his hard working. Do remember, hard work is very important. Yeah, now it's compounds with the a journal formula which is having the Grignard reagent where RMGX. It's very funny. RMGX, you can say. RMGX, where R is the alkyl or aryl group. Second, Mg, you know, is a magnesium. It's a magnesium, right? And the X is raised with the halogen. You can remember the chemical formula by enjoying the chemistry, not by the burden of chemistry. The RMGX, that is Grignard reagent. You remember? Yes, it's called as Grignard reagent. We have a journal formula on your screen. Please check if it is a Grignard reagent is there, if it is available in your lab. Yes, you can use. If it is not available in your lab, so you can prepare Rx plus Mg is equal to RMGX. My cat is, you know, fumbling me during the lectures. So yes, RMGX. So we'll have the, in presence of water, we'll have the alkanes and rest of the product. So you can see the example of Grignard reagent, that is a CS3CH2Br in presence of magnesium is, and in presence of dry ether is very important. You have to have the dry ether. If dry ether is not there, you cannot prepare the, you know, Grignard reagent. Grignard reagent needs dry ether. And the next is what? Yes, it's having the reaction where Grignard reagent give you the alkane, the C2H6. Okay, so this is the Grignard reagents. So yes, the next. These are the, you know, different preparation. Yes, these are the very important property of preparation of alkanes. Now we can have the another property, that is the reaction of alkanes. Yes, is a very important. See, don't be confused. There are two main properties in each and every, you know, preparation and reaction. Whenever you have to go for the formulas alkane, alkene, alkyne, you will have the preparation and you will have the reaction. Yes, yes. I think you will, you know. The preparation means what? How do you prepare alkanes from the rest of the thing, you know, rest of the compounds. And the reaction means what? How it will get react. Now I will give you some example. How will react when you know, when you saw in front of your, you know, superstar is standing, and how will you react? This is the reaction, you know. And how will you become a superstar? That is a preparation of yourself. This is the two different properties and very important. So now we can give the reaction of alkanes. This is very first and very important, that is the halogenation of alkanes. Yes, so we have the halogenation is the replacement of one or more hydrogen atoms in an organic compound by a halogen. So halogenation is the replacement of one or more hydrogen atoms in organic compound by halogenation. And halogen is what? You know, the fluorine, chlorine and bromine and iodine is the halogen. So you can remember this. Halogenation of an alkane appears as a simple substitution reaction. Yes, the very basic properties of the reactions are there. The types of the reactions are there. A substitution, addition, nucleophilic substitution, nucleophilic addition. These are the type of reaction. Yes, so you should remember how the substitution reaction take place. That means what? Substitution means a substitute one from another. One substitutes will, you know, take the other. That means what? Here what is happening? The H is substituting the X. Yes, in which the carbon hydrogen bond is broken and a new carbon and halogen bond is formed. That means what? H is substituted by X. That means what? H is substituted by halogen. Yes, remember, do remember. So yes, the chlorination of methane. Yes, here it is a reaction. Chlorination of methane will provides you the simple example of the halogenation of alkanes. On complication is that all that hydrogen atoms of an alkane may undergo a substitution resulting in a mixture of products as shown in the following unbalanced equation. This is the unbalanced equation. Yes, you see, you can have the methane plus chlorine and a chlorination, and then the plus energy. Energy is the main factor to perform, to synthesize, to do the reaction that will have the chloroform and the hydrochloric acid. Yes, the one complication is that all hydrogen atoms of an alkane may undergo again, see, remember, substitution, resulting a mixture of products as shown in the following unbalanced reaction. Yes, you have on the screen the unbalanced reaction of the methane plus chlorine and plus energy will have the rest of the product. Yes, so yeah, we have to have the very important factor, that is, yes, in the case of methane we have a large axis of hydrocarbons favors the formation of methyl chloride as the chief product, whereas an axis of chlorine favors the formation of chloroform and carbon tetrachloride. The substitution reactions happen in which the hydrogen atoms in the methane are replaced one at a time by chlorine atom, and you end up with a mixture of chloroethane, dichloroethane, trichloroethane and tetrachloroethane. Here it is. You have the the very basic reaction. How we can have the substitution reaction. Yes, it is a substitution reaction, you can say. Yes, see how the dichloromethane is formed, how the chloromethane is formed, how trichloroethane is formed, and the tetrachloroethane is formed. So remember, these are the very important factors of the the reaction of alkanes, right? So see, is the beauty of chemistry. You can enjoy chemistry. You can enjoy chemistry by by getting some of fun, by getting some you have, if you want to reduce the stress, you learn chemistry, you read chemistry. Yes, so yes, this is the all about the alkanes, the aliphatic hydrocarbons. If you want to know more about the how the chemistry is, beauty of chemistry, so please, this is the universal subject. Chemistry is a universal subject, so you can attempt, you can read, you can have master of the chemistry. So if you like my video, please subscribe. Okay, this is the Dr. Yaseen Ismail Sheikh from Abidain Amdar Senior College. Please subscribe. If you like, yes, please enjoy. And yes, just wait for another. Okay, bye, take care, have a great day.